In this video, we're going to take a look at solving polynomial equations. And in the first example, we're asked to solve x cubed minus 16x equals 0. And so one way, and I'm going to illustrate this only on this page, is there's some factoring that you can do to solve polynomial equations. Mostly on the other examples, so we'll take a look at using division methods. So for example, x cubed minus 16x, there is a common factor of x in these two terms. So if we factor an x out, we'll get x times, and if you factor an x out of an x cubed, you get x squared, and x out of a negative 16x, you get minus 16. Now this x squared minus 16 is the difference, there's the difference symbol, of two perfect squares. X squared is a perfect square because it's x squared, and 16 is a perfect square as well. It's 4 squared. And so x squared minus 16 will factor into x plus 4 and x minus 4. So now we have this original cubic factored into three linear factors, and so we can set each of these to 0 to solve for x. So if we set x equal to 0, we get 0. If we set x plus 4 equal to 0 and solve for x, we get negative 4. Negative 4 plus 4 makes this have a value of 0. And 4 is the number, positive 4, that makes this have a value of 0. 4 minus 4 is 0. So the three solutions are 0 and plus or minus 4. In the second example, we're asked to solve x to the 6th minus 25x to the 4th plus 16x squared minus 400 equals 0. And so another factoring you can do is actually a kind of common factoring. It's called factoring by grouping. Now, either of these could also be solved by the methods that I'll show you in the other 3 pages in the other examples in this lesson. Okay, so if you didn't see the factoring to do, you can still use the same methods I'm going to show in the other examples. So in the first, now notice that there's 4 terms. This is what might make me think to do this or try this. There's 4 terms here. So when there's an even number of terms, so 6 terms, 8 terms, probably not going to get too much bigger than that. You can do this factoring by grouping sometimes. So in these first 2 terms, there's a common factor of x to the 4th. So we're going to factor an x to the 4th of the first 2 terms. And in the last 2 terms, there's a common factor of 16. We can factor 16 out of 16x squared, leaving an x squared there. And if we factor 16 out of negative 400 divided by 16 is negative 25. Now, by factoring the x to the 4th out of the first 2 and the 16 out of the 3rd and 4th terms, notice what's in the brackets are the same 2 terms. And so, the same binomials. And so we could factor or common factor an x squared minus 25 out of both parts here. And so if we factor an x squared minus 25 out, what's left is the x to the 4th plus 16. You see, when you're factoring that binomial x squared minus 25 out, what you're actually doing is you're dividing this, when you're factoring the x squared minus 25 out, you're dividing both the parts of this by x squared minus 25. So that's why this is factored out. Once these divide out, what you're left with is x to the 4th plus 16. That's where this other binomial factor comes from. So we have 2 different binomial factors here. In fact, the x to the 4th plus 16, we said each of these equal to 0. And also the x squared minus 25. Now this actually has no real roots, because if we try to solve this, we would actually, if you bring the 16 over, it would be a negative 16. And so we would have x to the 4th equals negative 16. And so we would try to take the 4th root of a negative, and you can't do that. Now, if you wanted to write it as imaginary numbers, you could. Okay, if you want to get into non-real solutions, but there wouldn't be any real solutions there. So the x squared minus 25, you can factor that into x minus 5 and x plus 5, just like we factored the x squared minus 16 into x plus 4, x minus 4 here. And so 2 different factors, 2 different solutions, 5 from this one. Negative 5 is what makes that have a value of 0, so negative 5 is the other answer. So there's 2 solutions, 5 and negative 5, or plus or minus 5. In example 3, you're asked to solve this cubic equation, and we'll get into higher powers in the other examples too. We'll start with a cubic here, and you might recognize this symbol, especially if you're taking the course here, because it's a synthetic division symbol. And so we're going to factor this by using synthetic division. So we would write the coefficients 8, 10, negative 39, and 9 across the top here. Now, the numbers to try, of course, you're looking for factors that give you a remainder of 0. And so try factors of the 9. Actually 9 over 8, but we'll try whole numbers first. And it's trial and error. If you don't have a graphing calculator that you can see what the graph looks like, if you do, you can look for the x-intercepts. But factors of 9 are a good place to start, like plus or minus 1, plus or minus 3, and plus or minus 9. There aren't that many of them, really. And so I'm going to try negative 3 here, so we're checking to see if x plus 3 is a factor. And so we'll bring the 8 down, and 8 times negative 3 would be negative 24 here. 10 and negative 24 add to negative 14. So multiply the negative 14 by the negative 3, and of course that's going to be positive 42. And 42 add to negative 39 is 3. 3 times negative 3 is negative 9, and the 9 and negative 9 add to 0, and that's your remainder. So, I mean, through trial and error, maybe you might try a couple of numbers that don't work first, but you're looking for ones that do give you a remainder of 0. And so, we have factored the original cubic into x plus 3 and 8x squared minus 14x plus 3. This is the other, okay, there's the binomial factor. And so 8x squared minus 14x, 8x squared minus 14x plus 3 is the other factor from these three. And so in order to solve this, there's a couple ways you could do this. You could try to factor it and look for two numbers that add to negative 14 and multiply to 24. I'm using the method commonly called decomposition here. 8 times 3 gives you the 24. And those numbers would be negative 12 and negative 2 that add to negative 14 and multiply to 24. And so what you use those negative 12 and negative 2 for is to decompose or break down the negative 14x into negative 12x minus 2x. And so we do that, and then we do some common factoring, the factoring by grouping, just like in the previous example. And so in these first two terms, there's a common factor of 4x, so we can factor a 4x out of those two. So 4x out of 8x squared would give us a 2x, and 4x out of a negative 12x would give us minus 3. And the only common factor in the last two is just a negative 1. Remember, if this third term, or the first of the last two terms, is a negative, always factor a negative 1 out. There's really a negative 1 here, but we don't normally write the 1. So when you factor a negative 1 out of negative 2x, you get positive 2x, and a negative 1 out of 3, we get negative 3. And notice what's in the two brackets are the same. So we'll common factor a 2x minus 3 out, and so this is one factor. 2x minus 3 is going to be the other, and 4x minus 1 will be the third. And so we have our three binomial factors now, so we can solve to find the three solutions. And so negative 3 from this one, when we set 2x minus 3 equal to 0, bring the 3 over, be positive, divide out the 2, we get 3 halves. And the second one, the last one, second fraction one, bring the 1 over, divide out the 4, and we get a quarter. Now, we could stop there and say those are our three solutions. If you know in synthetic division other numbers that will work besides the negative 3, you could have actually continued those as well. So for example, I'm just going to show you this. Remember I said factors over 9 of 9 over factors over 8. So for example, 3 halves obviously should have worked here. So let's, I just want to demonstrate that that will work. So when we multiply the 3 halves by 8, and actually, let me go back to my pen here. 3 halves times 8, and let's see here. We'll do this right over here. 3 halves times the 8. The 2 goes into 8 4 times, and so 3 times 4 is 12. And so we put a, once we bring 8 down, 3 halves times 8 gives us the 12, so put 12 there. And negative 14 and 12 add to negative 2, and then we'll multiply that 3 halves by negative 2. And the 2 goes into negative 2, leaving a negative 1. So 3 times negative 1 would be negative 3. We'll put that right here and add those. You get 0. And so it, obviously to give a remainder 0. So 3/2 is going to be one solution. The other factor would be 8x minus 2. And if you solve that, you do get a quarter for the other solution. So just demonstrating that we could have used that fraction as well to factor it further that way using the synthetic division. And so we could have written that, the 8x minus 2. If you factor a 2 out of this and bring it in here, you get 2x minus 3, 4x minus 1, which is exactly the same thing as over here. And so you get the same three solutions. On to example number 4. And here we're going to solve a quartic or a fourth order polynomial equation. And so again, I'm just going to do some synthetic division. And so I'll try, we'll put the 4, 12, 3, negative 4, 12 in here. And so try whole numbers first. I mean, if you need to get into fractions, you can. So factors of 12, like plus or minus 1, plus or minus 2. I'm going to do negative 2 first here. Plus or minus 3, plus or minus 4, plus or minus 6, or plus or minus 12. So there actually are quite a few factors of 12 to try. So we'll bring the 4 down. Negative 2 times 4 is negative 8, and add it to the 12. You get positive 4. 4 times negative 2 is negative 8. 3 and negative 8 add to negative 5, and negative 5 times negative 2 is positive 10 here. Negative 4 and 10 is 6, and 6 times negative 2 is negative 12. Those are opposites, so they add to 0. And so nicely we get a remainder of 0. So x plus 2 certainly is a factor. Now, one thing I want to mention here is just because a number worked once doesn't mean that it won't work a second time. It could be that you have a double factor. So just want to show you that actually negative 2 does work a second time here. Actually, it's a double root. And so we'll bring the 4 down. We've multiplied 2 and negative 4 a few times here, so it gives us a negative 8, and that adds to negative 4. Now we're multiplying negative 2 and negative 4, so it's positive 8 here. Negative 5 and 8 is 3. 3 times negative 2 is negative 6, and again we get a remainder of 0. So we have taken our quartic and factored into x plus 2 squared, and then this factor would be 4x squared minus 4x plus 3. So that's what the 4, negative 4, 3 means down here. Now, so another thing that you need sometimes in solving polynomial equations is a quadratic formula. So I'm going to demonstrate that here. So we could solve 4x squared minus 4x plus 3 equals 0 by using the quadratic formula. And so there's the quadratic formula. So a is 4, b is negative 4, and c is 3. And so we'll substitute those into the formula. So putting a negative 4 here, negative 4 is positive 4. And then negative 4 squared minus 4 times 4 times c is 3. And then 2 times a is 2 times 4. So underneath the root, negative 4 squared is 16. And 4 times 4 is 16 times 3 is 48. So that we're subtracting 48 here over 8. 2 times 4 is 8. So 16 minus 48 is negative 32. And so there's some non-real roots here. I mentioned the imaginary earlier. We'll actually show those here too. The one real solution, of course, comes from the x plus 2 squared factor. If we said x plus 2 equal to 0, you get negative 2 for a solution. That's the only real solution here. Now, if you want to see the non-real roots written as imaginary or complex numbers, then we need to do something with this root of negative 32. So break 32 down into the product of two roots, one of which is a perfect square, and actually you want the biggest one. So 4 goes into 32, but 16 is the largest perfect square that goes into 32. So 32, or negative 32, is 16 times 2 times negative 1. There's the imaginary part right there. So the root of 16 is 4, and then we have root 2, and then this is I. I is the root of negative 1, or I squared equals negative 1. And one thing we can do here, actually to simplify this a bit, I'll go back to my pen again, is 4 goes into this once, and then a 2 in the bottom. And so we could write this as 1 plus or minus, and if you want to write a 1 here, you could. You don't really need to. Just write as root 2i. So 1 plus or minus root 2i over 2. So there's the two complex roots. There's only actually 3 different roots to this because the negative 2 is a double root. Power of 4, you expect 4 roots. So there's a double root here, that's 2, and then there's 2 more here. And example number 5, last one, we're going to solve a quintic or a 5th order polynomial equation. And notice that there's a common factor of x here. And so you'll see this once in a while, if there's no constant in the end, then you can factor that x out of the entire polynomial. And so I factored an x out, so we really only have to factor now the x to the 4th plus x cubed minus 7x squared minus x plus 6. And so in our synthetic division, we'll put 1, 1, negative 7, negative 1, 6 right there. And so we would be trying factors of the 6. And so I'm going to use 2 here, but again, trial and error. I mean, maybe you'll try a couple numbers that don't work, but you keep on going until you find remainders of 0. And then you're getting factors. So we'll bring the 1 down, and 2 times 1 is 2 here. 1 and 2 add to 3. 3 times 2 is 6. Negative 7 and 6 add to negative 1, and multiply that by the 2, we get negative 2. Negative 1 and negative 2 add to negative 3. And negative 3 times 2 is negative 6, and so we get a remainder of 0 when you add those opposites. So we've got one factor, but of course there should be 4 of them. So we need to try something again. So I'm going to use negative 3 in this case. Remember, factors of 6, negative 3 is one of them. So bring the 1 down. Negative 3 times the 1 is negative 3, and those add to 0. 0 times negative 3 is 0. Negative 1 and 0 add to negative 1, and then negative 1 times negative 3 is positive 3, and we get a remainder of 0. And so again, I've actually, I would be, if I didn't have the graphing calculator to check what the x-intercepts are, again, you just try in factors of 6. So you might try, numbers that don't work, like 6, for example, or negative 6, or negative 2. But, just trial and error until you actually get remainders of 0. So, x minus 2 is a factor. Don't forget about the x at the beginning here. This would give us a factor of x plus 3, and this is x squared minus 1. And so, x squared, there's no x, minus 1. And so, you could factor that x squared minus 1 into x minus 1 and x plus 1. It's actually the difference of 2 squares. And so, we have 3 different factors, so we have 3 different roots. And so, the roots would be 0, 2, negative 3 is what makes that 0, 1 and negative 1, so plus or minus 1. Now notice that 1 and negative 1 work, so you've actually could have kept the division going here, and I'm just going to demonstrate that. So for example, if you wanted to use 1, bring the 1 down. 1 times 1 is 1, so 0 and 1 add to 1, and 1 times 1 is 1 again. So if we add that 1 to the negative 1 above it, we get a remainder of 0. So we could have actually factored this into this completely. So we have the x from up here, the x minus 2, the x plus 3, and then this would be x minus 1, and the 1, 1 at the bottom would be x plus 1, and we would get the same solution. So there are other numbers besides 2 and negative 3 that would have worked in the synthetic division. At any rate, those are our 5 solutions. And that's the end of the video.